U.S. Technology Corporation, and today we want to show you how to remove the coatings off of a rotor blade. This rotor blade is from the CH47. The blade has been marked out in different spots, and these numbers here are going to be the air pressure that we will be blasting at in that area. The media of choice will be Depaint 3060 Magic. We'll be using a double venturi nozzle, and the operators, when they come in, will start at the one pressure in this zone, and when they finish that, then they'll change the pressure and go to the next zone. The blade itself is fiberglass up on the top, and on the bottom we have a titanium spar which runs the length of the blade. That can be done at 25 psi. The fiberglass section, which also runs the length of the blade, will be done at 15 psi. And as we get down towards the middle of the end of the blade, we have a section of lightning strike. The lightning strike, the top coating will be moved at 15 psi, and then the bottom coat will be taken off at 10 psi. As we get down to this end of the blade, there's another section of lightning strike, and this will also take the top coat off at 15 psi and the bottom coat at 10 psi. We're going to be doing all of this and showing you and teaching you how to do that. We're going to have two operators in the room at the same time blasting, and you'll be able to see that while you're blasting the Type 8 Magic media, there's just not a problem having two people blasting together. We'll get started in just a minute and show you how to do it.
Jerry's going to be starting down at the hub end of the blade. He's going to be blasting at 15 psi. He's using an optimum flow. This is with Type 8 3060 material. The double venturi nozzle allows him to be able to blast without a hot spot in the middle. The holes around the outside actually suck in air while you're blasting and open up the stream so that there is no hot spot. Depending on how thick the coating is on the blade is going to depend on how it comes off. The thicker the coating, it may take a little bit longer. We have Adam that started down on the other side of the blade, and he's blasting at 25 psi. Blasting with Type 8 material, because of the nature of the material, you can have two guys blasting in the same room and not have to worry about anybody hurting each other. This is at 25 psi. He's got a nice steady blast going. He's taking the material and he's blasting the paint off on a titanium surface. Back to Jerry. Jerry's on the fiberglass section, and you can see here just how fast that's coming off with an optimum flow. Very thin coating at this point. Adam's moving along on the bottom of that titanium spar, again at 25 psi with a nice steady blast. Now Adam has switched over and he's down the other side of the blade. The idea is to finish the entire section at one pressure so you don't have to be switching back and forth. That's very important. Again, a nice steady hand on the blast makes a tremendous difference. It allows you to move a lot faster than if you're jumping all over the place. He's got a nice optimum flow going. He's made himself comfortable, and he can go ahead and just keep removing those coatings. If you notice, there is a little bit of sparking coming off the titanium blade. This is natural whenever you blast titanium. You're going to get a spark. That's just a normal occurrence. And again, we can just see how fast that's coming off. That's just great. Why sand when you can blast? Also, the operator has to be very careful not to cover the holes with his hand while he's blasting. It's important that the material is fanned out from the air entering those holes. Here he is cutting the line from 15 to 25, just going down so he can go back and finish blasting that. He's doing a great job. These guys are experienced. I've trained them myself. Here is something you don't get a chance to see too often. This is called selective stripping. He's removing the top coat of the lightning strike at 15 psi. He's not going to go all the way down to the lightning strike because when we get to the lightning strike, we only want to clean it up at 10 psi. But you can remove the coatings on top of it. by selective stripping. And if you notice how fast he's moving, he's just taking that coating off with no problem. Top coat 15 psi, underneath 10 psi. Okay, what Jerry's done is he's just cut a line on a lightning strike so that he can see exactly where it starts and ends. We do mark it off, but the guys have done so many blades they can pretty much tell where they start and end, and that's some degree of operator skill being able to do that. This is not hard. Anybody can learn how to do this by going through a course. And again, we'd love to show up at your facility, teach you how to do this, and work with you with the Type 8 material. If all goes well and everything's running as normal, one blade with two guys can be done in about 4 hours. That's worst case scenario. If you've got regular Boeing approved coatings on there, one guy can do it in 4 hours. Okay, he's going to start the lightning strike now. The nozzle's been adjusted with the pressure down to 10 psi. And what he's doing is he's blasting from east to west, and then he's going to go from west to east and from north to south and then from south to north. By doing that, you're able to get out all the material. We're not worried about trying to take everything off on the first pass. So as you can see, he's just removing that at 10 psi. Again, a nice heavy flow coming out of the nozzle. And he's able to just clean up that lightning strike without doing any damage. There'll also be some still pictures at the end of this video that we're going to put in there, and I'll also tell you what they are and how it happened. This is such a big advantage over sanding, time-wise, but the best part about it is you're not doing any damage at all to the lightning strike. You're going to leave it the way it was repaired from the last time or when it was brand new and it was put in. And again, a couple of different angles, just cleaning it up as he's going along, and there you have it. Lightning strike at 10 psi, Type 8 material. It just doesn't get any better than that. This is a shot of lightning strike in the middle of the rotor blade, and as you look at it, you can see standing back how clean it came out and that there is no damage to the blade itself. It was blasted at 10 psi out of a double Venturi nozzle using Type 8 magic media. This is a close-up of the fiberglass fairing. It shows you all the little moguls that are in the blade and how nothing's been damaged, yet all the paint has been removed. Again, this has been done at 15 psi out of a double Venturi nozzle with Type 8 magic media 3060. This is the end of the blade where the lightning strike section is. You can see from the last time the repair was done that a lot of the lightning strike is missing. It was just a Bondo or a fiberglass patch put in there. And again, we didn't hurt any of this as we were removing it, but we've exposed what was underneath so that when it goes to overhaul, now I guess they will put new lightning strike back in there. Here's another shot of a patch that was put over the fiberglass and the lightning strike. It's hard to tell whether this was done in the field or whether it was done in an overhaul shop, but again, when we remove the coatings, we leave the patch of all the previous work intact, so when it goes to overhaul, they can make a determination on how they'd like to fix that. Again, here's another patch. You can see the little bit of Bondo that they left around the outside of the patch, so they could get a smooth surface when they were repairing it. Again, able to remove all the paint off it, leave the Bondo and the patch intact. When it gets to overhaul, once again, they'll be able to make a determination what they want to do with that. Here's a real close-up of the lightning strike. This was taken about 6 inches away from the surface. 10 psi, Type 8 material, 3060. What a surface. That is left in absolutely beautiful condition. Again, here's another repair that's right in the middle of the blade, left intact, fiberglass, and the Bondo around it. Here's a shot of the transition route where the identification tag has been taped up. You can see that there's some repair work done around it. We were able to leave everything intact, not hurt the tag because we double taped it, and again, ready to go to overhaul so they can make a decision how they would like to proceed on it. This is a photo of the blowout patch in case the blade gets hit by lightning. At 25 psi, we're able to remove all the coatings, still leave the Bondo and everything around that patch intact.
You've just seen CH47 rotor blades being stripped with magic Type 8 3060 plastic media. This is cutting-edge technology brought to you from US Technology Corporation. All across the country, rotor blades are being sanded with orbital sanders. The results are waves in the blade and a compromised surface. It's also a very labor-intense process, costing between 30 and 40 man-hours to complete one blade. You've just seen a better way. With Type A 3060 Magic, you'll be able to save time and money. You'll be able to remove the coatings from the blade without compromising the integrity of the surface of the rotor blade. In the still pictures you just looked at, we showed you previous patchwork done to the blade. Blasting with Magic at low pressures, you will still be able to remove all the coatings with no damage to the surface or to the fiberglass patchwork. Even where the fiberglass has a textured surface that of a golf ball, you'll still be able to remove all the coatings from that and leave the surface intact. The most impressive part of this video is where we can remove the coatings from lightning strike with no damage to the lightning strike. Like what you see, we'd be happy to come to your facility and do a demo for you. I'm sure you got questions, so give us a call. I'm Vinny with US Tech, and I hope to see you soon.